Hello, and welcome to this week's edition of Google Cloud Talks by DevRel. My name is Yufeng Guo, and this week we are focusing in all about DevOps again. 2 weeks ago, we did our first DevOps session, and we're really excited to bring back two exciting speakers to talk to us more about DevOps. And so if you're just joining us for the first time to these talks, Google Cloud Talks by DevRel is kind of this ongoing series of sessions presented by Google developer advocates to address topics that are kind of most important to you, the dev community. Today's session will be all about DevOps, and next Tuesday, not Thursday, but Tuesday, May 26th, we're going to have a great session on practical AI. And so you can always find out more information about these upcoming sessions, and you can register on our site. The link is down below in the description. And so if there are more topics that you'd like to see in the future, share them with us through the Q&A that we're going to have. So now let's turn to today's presentations. We're thrilled to have Jaana Dogan and Don McCasland joining us to talk about Go and all about kind of CI/CD processes. So let's go to them now here. Jaana, she was an engineer on the Go team for 4 years and was the tech lead for several parts of Go support for Google Cloud. And so she's here today to talk to us all about the whole language of Go, basically, and how we can use it in the cloud. So really excited for that. And after that's over, be sure to stick around for Don McCasland's talk. He is a developer platform engineer. He's focused on CI/CD systems, and he's got over 20 years of experience in DevOps and release engineering. So that's super exciting. And we're going to learn all about how to secure our container build pipelines. It's something that I personally have been kind of curious about as I've kind of experimented with pipelines in the machine learning realm and containers. And this area has really been quite the challenge, shall we say. So let's welcome on now. Jaana, Don, how are you doing today? Thanks for joining us.
Hi, how are you? It's really early in the morning for me, and this is Pacific time. uh, yeah.
Yeah, we're doing great over here in Oakland, California. It's a sunny day. Yeah, looking forward to getting some outside time later.
Awesome. And so, yeah, in general, we're able, it's so great that we're able to kind of come together in these times where we're all separated, but joined together in these kinds of virtual events and bringing in all these viewers from around the world. Folks who are watching, there is a live chat. Feel free to say hello. Let us know where you're tuning in from, what you've been up to, what you miss about the before times, as it were, and and what you're looking forward to today. Why what are you hoping to learn today with Jaana and Don?
This is actually so much easier than traveling around, but I'm not sure about it was also super nice to, go and like meet people in person.
Yeah.
But I'm seeing definitely maybe virtual conferences becoming more of a thing in the long term, even after, COVID-19.
Totally.
Yeah. I tell you what, I do miss the conferences. I miss speaking to people directly. I love talking to people at the booth and hanging out and hearing their ideas. But this time has been a really interesting time for me because I've actually gotten interested in hobbying again and doing things around the house. Now's a really good time to pick up a new programming language. Now's a great time to pick up the cloud. I've picked up 3D printing again.
Very nice.
It's been a really interesting time here.
So do you have any
What language are you picking? Sorry.
No, go ahead. Yeah.
Actually, I haven't picked up a new language. I have been delving into Google Cloud a little bit more. That is my job, but there's time to actually get into the nooks and crannies a little more. And then 3D printing is super fun. I've actually learned to use a parametric modeling system as opposed to the classical modeling systems I'm used to. Yeah.
Wow. We'll have to get you on I guess a different show, but something where 3D printing would be relevant. I want to learn more about that. It sounds really cool. And we see on the live chat, one of our colleagues, Dave, says hello from Jersey City and has a message for Jaana about not checking out his Go code that he's been trying to learn. So that's funny. And we have
Oh,
a
Yeah.
comment from Philippe Martin, joining from France, where it is quite late. So thank you for staying up to be with us, Philippe.
international.
That's right. All
I
right.
was
So,
specifically asking the language question because I want to learn Kotlin.
oh,
This is the perfect time, probably.
I've only built Kotlin. Like, I did a lot with Java for years, and then we switched from Java to Kotlin for app development, and it builds just the same.
it's funny. All right. So I guess with a couple minutes in here, why don't we get started with Jaana's presentation all about Go in the cloud? And
Okay.
in a little bit, we'll have Don. Don will stick around, and he'll come back for the second presentation today.
All right, break a leg. See you in a bit.
All
All
right.
right. As I mentioned, I worked on the Go project since the very early beginnings, and this is one of the current questions that is coming to us very often. The question is Go the language of the cloud or not? And to give you like a little bit history, I was also one of the TLs of the Go support on Google Cloud. And when I first started 6 or 7 years ago, Go was still new and there was a lot of like skepticism. And in the context of the cloud, majority of the world was not considering Go at that time, although there were a few very successful projects. And from our perspective, it was very hard to start a new language support for a very large organization. So there was a lot of skepticism, but we knew in the beginning that Go is going to be a significant player. So first, I want to address what it means to the language of cloud. I think there are two reasons that this confuses people. The first part of the story is, cloud is language agnostic. It has nothing to do with one language or the other. But the second part is there are a lot of people, especially in the larger community. If you think about the cloud native projects, there are a lot of projects that is completely written or started in Go. So this entire ecosystem has a lot of Go bits in it. One of the biggest contributors to Go's success was actually Docker, because Docker wasn't initially written in Go, but after they rewrite everything in Go, and it became a very popular project. The other parts of the ecosystem decided to pick Go for consistency. Kubernetes initially picked Go for this particular reason because Docker was already there and some of the tooling and the API and the client libraries was in Go. So they just wanted to have that level of consistency. Also from the perspective of contributors, Docker actually helped a lot of people to learn Go because people were trying to contribute to Docker. So Kubernetes also saw that association. Today, almost like every CNCF project is written in Go. And I think what people mean when they say Go is the language of cloud, they mean this is a language designed with modern concerns for stuff that you would run as cloud workloads. And provides productivity to the users they need in that context. But also they mean that, this is the language adopted by major infrastructure and tools, and sometimes considered even as a go-to choice. And today's talk will be not about the historical things, but it will be more of like a retrospection for me to explain you why some of these things happened, and why we were almost very certain that Go is going to be very impactful in this area because of the features it has. So I want to talk about the language features. And the first one is Go has extraordinarily, significantly small binaries. Go is a compiled language, so you just produce a binary in the end. And one of the biggest problems with this is with other languages, you either have a separate runtime like Java, you have the JVM, plus some binary objects that you run on that. And the total number of components involved is usually large in terms of megabytes. In Go, the final artifact with runtime dependencies and everything can be as small as 20, 25 megabytes. And the size is actually getting better at every release. This helped us to have build artifacts that is very small, easy to deploy, and also really help, containerizing things. If you're building a Docker container with a Go binary, it's going to be small. It's going to be easy to just move around and deploy. And it's really good for serverless environment as well. The other thing has been the build static binaries. As I mentioned, Go is taking a bunch of source files. It converts them into this intermediate form, and then linker is taking everything together and producing the final binary. So I'll switch to my terminal for a second. I have a very tiny Go program here.
Hey, Jaana.
And yes.
A small note, as you switch to your terminal, you're actually not sharing your screen yet.
Okay.
Can you share your screen to the
Sure.
Yeah.
That is a huge issue, sorry.
Yeah. I didn't know if you just wanted to talk a little bit at the beginning, so then when you started saying switching to the code, I was like, maybe we should show the code.
I had some slides, but slides were very minimal, so that's completely fine.
All good.
This was the slide I was actually at. So, we have a bunch of Go files. We put them to, compilers taking them, converting them into the intermediate thing and producing the binary. And I was about to show you that I have a very small program here, a very, small hello world. And you use Go build. So like all that like compilation and linking is taken care of by the Go build. You don't necessarily see the details of it, but it produces a binary. And when you run it, it just runs. So one thing that I was talking about was the programs file into this static binary. So it just really simplifies the delivery process. In CI/CD systems, for example, people just like take this binary and then completely, just sometimes copy paste it or like containerize it and deploy it. The other feature is fast builds. One of the, I think, most criticism around compiled languages is they are very hard and it takes a very long time to compile them. One of the reasons Google initially invested in Go was the fact that they needed faster builds. So Go has a very fast iteration cycle. You make a change and in less than a second you can recompile and start the server again. And even though, we have the strongly typed language, fast builds have almost made it feel like it's a Python or a Ruby because the iteration is so fast. And people enjoy the fact that, there's type safety in it. The iteration is really fast, regardless of that. It's a really good combination. I talked about container images, and one of the reasons that people love Go is the fact that how easy to build container images. In this slide, I actually have a Docker file. Like this is an actual Docker file that I've been using for Google Cloud Functions. It really fits into a slide like this. And it's a two-phase Docker file. So in this phase, I'm building by using the Go toolchain. And in the final stage, I'm actually taking a base image with almost like no dependencies, like a very small container image, and copy pasting the final artifact, which is the binary app here. So people love it because it's just easy to build. It just doesn't require a lot of work to build container images. Although things are not as easy as Go build, and I think we can do some more work around this, it's still, I think, fine. The other thing has been the cross-compilation support. So cross-compilation is a huge issue. And there's a ton of Mac and Windows users, but our production systems are mainly 64-bit Linux. Cross-compilation is always very complicated regardless of what language you go. In Go, it's slightly better. And like lots of people actually like dependent on cross-compilation in a lot of cases, especially if they don't have any C or C++ dependencies. In order to cross-compile, you basically come here. Rather than typing Go build, you say Goose. We pronounce this as Goose. And this is the Go architecture, but we say Garch. And you can say, AMD 64 and, Go build. And the binary it produces, hello, So I'm currently on a Mac. It's not going to run because this is a Linux binary, and this is how I proved it. I can't start hello. So this is how you can build, easily all these cross compile to different platforms. And one of the popular reasons for this is like some people even trust the cross compiler, especially if they don't have any other C dependencies, so much that they cross compile on their Mac and then put their binary to the Linux containers. That's something. The other feature has been very important for Go's success has been the runtime initialization. It's really fast. Go is a very popular choice for writing command line tools for this particular reason. But for servers, it all actually matters too, especially if you're writing auto-scaling servers, if you have like serverless workloads. Cold start can be affected normally by runtime initialization. When I mean runtime initialization, by the way, I mean the time it takes for you to hit to the main function, because the runtime has to initialize. Every language has a lot of things to do. Some languages like load dependencies, initialize runtime, scheduler, and all of that, like the garbage collector and so on. So what I mean by runtime initialization is the time it takes to hit the main function. And in Go's case, it's really fast compared to some of the other languages, such as JVM languages. And this has been a really good contributor to us because it's just easy to auto-scale things up and down. And one of the particular reasons that this was such a big concern for a lot of users initially, I think the entire ecosystem contributed. If you're thinking about, for example, HTTP libraries or RPC libraries, people seem to be caring a lot about the startup time. In other ecosystems, if you go to, for example, Java, you may see that it takes a long time for some of the frameworks to be loaded and so on. We don't see something the same thing in Go, because I think it was a part of the good parts of Go in the beginning, so everybody contributed to that. Go had a very good built-in library around networking since the very beginning. The net and net HTTP package contained a lot, like TCP, UDP, DNS support was there. But more interestingly, Go had HTTP support out of the box since the day one. And actually, they really contributed a lot. Like, for example, they added HTTP2 support. So you can switch to HTTP2 from the HTTP package in the underlying layer automatically because the language had support for that. And as an addition to these rich networking libraries, RPC frameworks contributed a lot. One of them was gRPC. When gRPC was first coming around, they were considering Go as a significant language. So they had 4 major languages that they really deeply cared about, and Go was one of them. And since we have, a very small subset of these core libraries, I think the real advantage is these are canonical libraries and share the common abstractions. So if you go and take a look at any HTTP library or framework, it's dependent on the abstractions available in net HTTP package, and it's making the whole ecosystem actually very working well together. The other thing was the concurrency features. Go routines was one of them. So these are lightweight threads. In this particular case, I'm just starting 5 lightweight threads that prints out hello world. You just use the Go keyword to do that. It's just so amazing. The scheduler is distributing these Go routines on available OS threads and just takes care of life cycle and everything. It's very simple. And for concurrency and workloads who are servers, this is a huge feature. On top of Go routines, we have a lot of concurrency controls. One of them is channels. Channels allow you to talk between Go routines. You can use them also like communicate in a single Go routine, but the main reason they exist is like they allow you to communicate between Go routines. And the select statement, for example, I'm demonstrating here is a masterpiece. It's an orchestrator. You can read from like multiple channels. You can, do all these interesting things. And one of the, the reasons that Go programs tend to be readable is the fact that we have this select as an orchestrator. The other concurrency control features are mostly in the sync package. Like one of them is, for example, wait group. You can just basically have this wait group waiting on multiple things, helping you to orchestrate. Sync package has some other controls. So take a look at the sync packages. It's really good in terms of, handling some of the more complicated concurrencies. I briefly mentioned that scheduler was a huge, actually, contributor because Go is a modern language, so it definitely scales to all the actual processors, physical processors you have. But more interestingly, with the Go routines and the way that they are actually running on OS threads, the scheduler is doing some more work. It's not just distributing a Go routine onto multiple processes, it also starts all these like operating system threads that actually runs the Go routines because, we don't want to necessarily mess up with threads ourselves since they are heavier, harder to start, harder to manage, and whatever. So Go didn't really make that distinction and didn't expose any APIs related to threads. You as a user are always working with Go routines, and the scheduler is taking care of the distribution and everything. In this case, you're looking at like a 2-processor system that runs some OS threads, and 2 Go routines are scheduled to run on those threads. We have written some articles on the scheduler. Scheduler is a very interesting part of the Go and why it became, I think, interested for server workloads. So, you can take a look at them. In the context of this talk, I will switch to something else because this is a huge topic. The other, I think, differentiator for Go was the introspection in production. We had, memory stats, just everyone else, but we had also pprof support. Pprof allows you to profile things in production, which is something very new for a lot of people because, profiling is traditionally very expensive. And I will briefly explain how we do it. And then there's execution tracer, which is also very nice. Like you can see all the runtime events and scheduling of the things and so on in production. It's slightly more expensive, but it's still possible to turn it on in production and take a look at what's going on and then kind of, turn it off. And Go since the beginning provided post-mortem debugging. So you can either debug things in production or you can just take dumps, or you can take a look at the crashes and do post-mortem debugging. So these are like some of the very core features that contributed, and you can always do things better. I realized that there are some gotchas that people haven't considered when working with this language, and I can briefly explain some of them. The first one is we don't want you to ship your toolchain in your production containers, so always use this type of like 2-phase container images. Keep your production container image as simple as it is because Go builds artifacts. In the end of the day, you need something like this Serverless base type of image and your binary and maybe some certificates and that type of stuff. The other thing is Go is releasing every 2 times every year, and it's very important for you to keep deploying, rebuilding things with the new Go releases. You can take a look at the binaries Go version by running Go version binary command. This is a new edition, by the way. And there's another project that I started, which is this github.com Google Go PS, which allows you to just inspect the binaries you are currently running in your system and reporting the versions. So you can figure out the older versions and recompile them and release. As a good practice, always like embed your commit versions. And as a side note here, Go build is very opinionated, but you still can have like build constraints and other options when you're building things. So make sure that you are also embedding those bits into the commit as a additional to the commit versions, so you can reproduce the builds. The go command can report also module information and about the dependencies. In the case you're dependent on a lot of different things, and you want to inspect a particular version, if a particular version has gone into a binary or something, you can run go version -m binary, and it is going to list all the dependencies, and as well as like some of the interesting features of the module, such as the Go version. It's used to compile the module's path, the version, and so on. One of the gotchas of our customers is serverless functions are servers in Go, because this is not like Python. Like, you can't really fork, a process every time. So if you provide us, for example, for Google Cloud Functions, you provide us a function, hello world, in this particular example, and then you can deploy this by running G Cloud Functions deploy. But what we actually do is converting this, putting this into a server, and then running the server and serving this particular request from that server. It's really important to know this, because things may be reshared. So you may, if you don't consider the life cycle of this server, there might be possible data raises. You may see some of the background routines may be killed prematurely, because serverless environments auto scale things up and down. And sometimes graceful shutdown is not available because these platforms don't provide a lot of support for signaling things. So just be careful. Make sure that you understand these concerns, so you don't make significant mistakes. And one thing that lots of people are missing is graceful shutdowns. A lot of libraries such as the HTTP server, for example, provide some cleaning up methods. And when you're especially auto scaling things and down, it's important for you to stop, accepting new requests. And the HTTP package kind of allows you to do this by running the shutdown. So the load balancer can take the request and reroute it to another available server. Always report metrics. Go has a lot of metrics available from the runtime package. The number of Go routine threads, CGO calls, the memory stats. These are important metrics to take a look at. Go can also print out scheduling and GC related events. People use this type of stuff, especially in production. The output is a little bit hard and cryptic, but there are tools who can parse this, and the team is actually improving the output. So we're not going to do. Go allows propagating the context, by the way. So make sure that you are utilizing this in especially microservices environments. Context is really important. And HTTP package made use of context at a later stage. We introduced this concept to the language at a later time. So make sure that you're also using request context, because it looks slightly API-wise different. As I said, you can continuously profile in production. This is possible due to pprof, because pprof is a lightweight way of collecting things, and it additionally adds maybe 5 or 10%. And this is really good for fleet-wide hotspots. Don't prematurely optimize things. Always profile in production and try to see the actual hotspots coming from the production environment. One of the things that we released related to this is our cloud profiler, which is enabled by just importing a package, and then it just reports these profiles once a while, and it then puts everything together, and you can either A/B test, or you can just go and dig in and see a particular instance, or you can see the differences between versions and so on. So you can also take a look at this cloud profiler, which is a good way to see. The other thing, and this is going to be my last thing to mention, it's possible to debug in production. What you can do is set this Go traceback crash, traceback environmental variable to crash. And if this particular thing crashes, or if you send a signal, it's going to dump a core file. And then you can use your debugger to basically just take a look what's going on, exactly where it crashed, or you can investigate basically the state variables and do all sorts of other things that you would do with your debugger with a core file. I've written an article on this, by the way. If you search for probably, core files and you will be able to get to it. We're running out of time. There's a lot to talk about, but this is all from me. I tried to, briefly summarize the core features that contributed to Go's success and some of the gotchas that might not be super obvious. And if you have any questions, I am very happy to answer. There is one question about can we have more details on embedding build details? So this is, yes, this is not a part of the Go toolchain at this point, but Go linker allows you to inject some values. You have, for example, a package, a package level variable. You can set the value by using the linker. So when you're running Go builds in your CI/CD system, you can inject some values. And there are some tools to do this. Like you can build everything from scratch yourself, but there are some tools for it. If you search for it, there are many tools, and I don't want to, just favor one or the other. But if you search for it, there are tools that exactly does this. It takes a look at the Git, the current revision of the head. It automatically takes it, and as well as it embeds, I think, the builds, some other information, such as the committer, which is useful because when you want to find a contact person, you just need at least the last person committed this without even really have to go to the repo and check in by the hash who committed. And that's all I have. And we don't have, I think, more time, right? And we don't have any questions. So
yeah,
it's all you. Thanks a lot for having me.
Yeah, thanks so much, Jaana, for joining us, and thank you everyone for joining us. We're gonna have Don join us, and he's gonna talk to us about these pipelines. I find that it's a really nice pairing, these two talks. You're talking about there's Don. Let's and so yeah, in terms of the combination, right, of Go and the build process and things like that, and talking about how it differs from a lot of the languages that have come before it, and what you said about Go being a truly modern language, it really resonates, I think. So that's really great. Don, whenever you're ready, feel free to take over the presentation and get set up.
All right.
Yeah, and if you have any other questions or thoughts about Jaana's presentation, for questions for her. Yeah, and people can continue asking questions in the slides. We have a question here about from Leonard, who asks what books you'd recommend for folks who are learning.
I personally like Ellen Donovan and Brian Kernighan's book, but people think that it's not, it's just a really good overview of the spec and the fundamentals of the language features. If you're looking for something more practical, maybe it's not a really good starting point, but it's actually the type of the textbook that, I would read if I was just learning Go, or if I generally want to understand some of the historical reasons why some features came around. And Brian Kernighan, I used to read his books, and his work at Bell Labs is just extremely interesting. And I think we're very lucky that he contributed with Ellen to write that book.
It's great. Yeah, Brian Kernighan's a titan of industry, a legend.
Exactly, yeah. Thank you a lot. I think this is all.
Great. All right, let's switch over to Don. Yeah, thank you, Jaana.
Thanks, Jaana. A lot. Well, I am definitely going to learn Go now. I had started down this path, but I got a little stopped previously, and I'm really inspired to go back at it. I had actually stopped learning around the concurrency parts, and I didn't realize how easy it is.
Yeah.
I'll point out later in my demo where Go would make my world a little easier.
Amazing.
All right. Well,
take it away.
Are we ready?
Yeah, all right, we're all set.
Let's see here. Let's make that big. Here we go. I think we're ready to present. Hey, everybody. Welcome to, hopefully, I think we are going to cover this information pretty quickly. A short presentation on using Cloud Build with vulnerability scan attestation. Say that 3 times fast. I have, just to practice. So we're going to talk about using, building up a secure software supply chain today. But first, let's talk about what is an attestation. Here's your dictionary definition. It's evidence or proof of something, right? A declaration that something exists or is the case. The way we use it is simpler and more complex both. Cryptographic proof of a software status. In the past, you may have heard this referred to as code signing. Code signing is an attestation that a piece of software comes from a particular provider. Your iOS apps coming from Apple, for example. Your phone actually checks that it has a certificate that matches the root of trust provided by Apple. This is an important thing. This allows computers to check to see if the software is what it says it is. If it's past a certain bar, you can use attestations to say where the software is from. You can use an attestation to say that has been manually approved by the DevOps crew to be deployed. You can use it to say that it passed a certain testing bar. And this today, we're going to use attestation along with container registries vulnerability scanning to build up a secure software supply chain. So let's talk a little bit about container registry. Google Container Registry has a feature in it called vulnerability scanning. All you have to do is turn it on, and it will look over every container that you push to it and make and look for known vulnerabilities in the package. It checks this from publicly available databases, which are constantly being updated. And your containers are also being constantly scanned. So if you look one day, you might notice that your container has a certain set of known vulnerabilities, but we find, they have found a new one in, let's say, OpenSSL. That's always our favorite picked on package. They found a new vulnerability. Today's scan will show you that that new vulnerability exists, or, and this is super important to you, that a fix is available for that vulnerability that was previously found. If a fix is available, you probably want to rebuild and redeploy, making your production servers more secure. Container analysis is based on an open source project that we originally authored and then released. A lot of companies have added to it over time. And we use it. We actually provide a managed version of it as container analysis. And today's demo is based on this. You can follow along today's demo at home by going to GitHub, Grapheus/Critis. If you go there on GitHub and then find the samples signer directory, you'll find a README. And the README is going to be really, really simple because that's the way we want it. So we've taken all the hard parts about setting this up and stuffed them into a setup script. We're not going to run that setup script today because it takes about 30 minutes to run inside of Cloud Shell, shorter on a other piece of hardware. But the cool thing is, if you open the README, you'll find a button down on the bottom. If you click that button and you have Google Cloud Platform set up, it will open this project. It will clone this project in Cloud Shell with all the tools necessary to start using it. The setup script, as I mentioned, does a bunch of things for you to use binary authorization and container analysis. It enables all the APIs. It sets up your service accounts it creates a custom builder in Python for a Python snippet that I wrote that scans the container analysis to make sure that it has finished. Talk about that in a minute. Here's a place where the Go language would be simpler. If I'd written this snippet in Go, I would not have to create a custom builder here. I could just use it as it exists. There's an exercise for me later on. The next thing it does is it creates a custom builder based on the Critis code. The Critis code is used to make sure that your container that you've just pushed passes a certain security bar via a policy that we'll go into. And if it does, it will attest to that passing that bar. It will create an attestation and push it up along with your container. The last thing this does is actually create an attestor, which is the thing that binary authorization uses to make sure that any container you try to deploy has an attestation. I know that's a lot of terms. All of this is explained in our documents. If you look up binary authorization, there are key concepts that disambiguate all of this. The last thing we're going to do today is actually use Cloud Build. This is going to be the shortest part of our presentation. We'll start Cloud Build, and you can see along the bottom here, it goes from one step to the next step to the next step to the next step. It creates a container. We're actually we've got a positive case and a negative case, so you can see both. You can see a container passing, you can see a container failing. So the container that passes is basically just Debian 10 within Nginx. And then the one that fails is Debian 9 with Nginx. So we create the container, we push it to container registry. Container analysis starts automatically. So when we go to the next step in Cloud Build, we wait for that analysis to complete. Once it's complete, we go to the next Cloud Build step, which uses the Critis signer to check the analysis results against the policy. If it's correct, if it passes, we sign it and we push an attestation to container registry. That's it. We can come back to this this graph here in just a little bit, but let's try going over to Cloud Shell. Let's make sure actually anyone has asked me any questions. No. Okay, cool. Let's go to Cloud Shell. So when you click that button, start in Cloud Shell, this is what you get. What is Cloud Shell? So Cloud Shell is this cool thing in Google Cloud Platform. If you've got a project like this, you can find it by clicking here, Activate Cloud Shell, or from GitHub, open in Cloud Shell, and you get a shell. And the shell has everything pre-installed, including the authorizations for working with your project to get to work. It also opens this clever IDE, which is really useful for examining your tree. So here's my Critis tree. If we see here, we go down to samples, go to signer, see all the files. I've got setup.sh here, so you can see in setup.sh, this is what it would do. If you run setup.sh later, by the way, it will echo all the commands that you would have to do yourself and tells you what it's doing. And then it gives you a lot of output. It gives you too much output. I need to make that clever. But we're not going to run that today. We're going to go into Cloud Shell open, Critis, samples, signer. There we are. Now we have a Docker file. Good. Let's look at that the good Docker file. This is it. It's very simple. And now let's look at the Cloud Build good. All right. This is a little less simple, but I'll show you what it's doing. As 4 steps, as mentioned, we build the Docker image. We push the Docker image. We wait for analysis. The code for that is here. You can replicate it, hack it, do whatever you want with it. And then we pass it on to the Critis signer, which uses some credentials from your service. It also uses keys that were created during setup to sign the image, and it checks it against this policy. This is our policy that we're going to use for both good and bad example. Let's look at this policy. So this policy says something really simple. Basically, the vulnerability bar that this image must pass is that if a fix is not available, the maximum severity of vulnerability present is medium. All right. So if otherwise, if a fix is available, the maximum severity is medium. So the documentation for this policy is in the Critis repo. You can take a look at it. Let's actually look at vulnerability analysis real quickly and look at the images that we're going to check against. So let's look at the latest good. So this, I ran this before. You can see that in the latest good image, we have a bunch of medium vulnerabilities that are known. You can go click over to the documentation for this, and you can see that it's a something to do with XML schema pre-run. You can get more and more details about that. Let's look at the latest bad. The latest bad image has a bunch of high impact vulnerabilities. So we want to reject those. But these are not the images that we're going to use, actually, because we're going to regenerate. We're going to do this on the fly so that you can see vulnerability scanning actually start off. All right, so let's run it. Dun, 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 dun. G-Cloud build submit config equals build good.yaml. Terrible typing. When did that happen? Okay, here we go. And we're running. What did I do? G-Cloud builds submit cloud. They say your typing is the worst when people are watching. Okay, here we go. So it's running. Let's actually pop over here to cloud build, type it in here, go to cloud build, history. You should see one that's running. Exciting demo, loady. All right, so here we've already started getting logs. We're building the Docker image. We're pushing the Docker image. Here we are. Now we're polling. We're actually running a piece of code that's asking container analysis, are we done yet? Are we done yet? Are we there yet? And let's actually look now at the container registry. So created just now. Oh, it does look like analysis has finished. So excellent. So analysis finished, and then we went to the vulnerability signing portion. And you can see here that the policy requirement was passed. And so we created an attestation for the image. And so it's been signed. And here we are, success. We like the answer success. Okay, so again, let's look at this. We see that this image only had medium vulnerabilities. Now we're going to do the bad image. You're going to see it fail because we love failure cases. We'll get this going. And again, so the Docker image that's bad is just Debian 9. And Debian 9 has some known high impact vulnerabilities. This is why we use Debian 10. Go over here, refresh. Not there yet. Ah, here we go. We're pushing. Okay, so let's refresh. We see latest, and this is also latest bad. The scan is queued. This is cool. Refresh again. Scanning is happening. We love that. Refresh again. Still scanning. All right, so we're scanned. Let's refresh again. We can see over here we have some high impact. I know it has some high impact. We'll refresh in the middle in a minute. Oh, failure. This is what we wanted. We love a good negative case. So let's actually look at what it said. So it was validating this image against the policy that we created. And it says error creating the signature. It compacts this information pretty closely, but you can see which CVEs it found that were a problem. So this is an example of shifting left security. We are testing our images before they even make it to production. So this build would fail. And we can actually see it over here in cloud build. Load that up. Yeah, you can see it failed right here at the vulnerability signing portion. So this is great. We love that. But we know from our discussion of container analysis that the analysis part is always changing. So we know that analysis is an ongoing thing. We know that like this same image might seem secure today, but we'll find out something new about it later. So how do we deal with that? The way that we deal with that, we'll go back over here to this image, is with binary authorization. So you'll remember that the setup, and a testor in binary authorization. Let's take a look at that real quickly. Click over to IAM admin, security, and binary authorization. We can see a policy that's here. Allow only images that have been approved by all of following attestors. Here is an attestor. This is it. It talks about the public keys. So let's do what we might do to deploy this, the cube control. We're going to try to run this image on our cluster, and we will see that it could not be run because it was denied by this attestor. That's the whole demo. It was a lot of talk and very little do. All the doing was handled by machines. This is the way we want it, isn't it? All right, so let's see if there are any questions available for us. No questions today. So if you have any questions, you can post it to the link. All right.
So Don,
Yufeng has come back.
yes, hi. Yeah, thank you for that presentation, Don. That was really interesting in terms of just seeing how much built-in functionality we have in our cloud build systems. And as I start talking, we do have a question that coming in here. Are the examples that we have, the cloud build bad, cloud build good, Are they shown? Are they available online for folks to try for themselves? Leonard asks this question about kind of, is this maybe in the GitHub repo perhaps?
They are, in fact, if you go to Grapheus Critis right now, the everything that I just showed you is there, including the setup script, the good and bad Docker files, and the good and bad cloud build files.
Nice. And that's in that signer folder, it looks like?
Yeah. Sample signer. We just landed this, and we are making some more modifications to this, thanks to Kifan and others. Some more is coming down the pike, but yeah.
And so we have another a question here from Tibor. He's a regular viewer of the channel. He's asking about security scanning. That looks like it's built into the cloud build function, and as a practitioner, I know that my deployment is being scanned for known vulnerabilities by default, or did we have to set things up kind of more manually there?
Well, actually, so think of it this way. So your containers are being scanned. So what you want to do is watch the containers that are deployed for any new vulnerabilities, or actually, just as importantly, new fixes. Let's actually show you what that looks like in our registry. So if you go to container registry and you go to settings, you basically can turn on, you can enable or disable and vulnerability. If it's on, everything gets scanned. Here's an important note, and this is in the documentation. You will only scan those images, those containers, that have been used recently. So we'll stop actually scanning them if they're not in use. But for your deployed containers, they continue to be scanned. So you're not actually spending compute cycles, or we're not spending them. I don't think there's a cost associated with this. But so you're not actually, scanning everything that you've ever presented. If you're in a big enterprise, one registry can have tens of thousands of images, but only a few of them are being used regularly. So in this case, because I've been doing a lot of work on this demo and so forth, all of these are being scanned. But I think you can actually maybe pick another one, an old ASP.NET Core. You'll see that it's stale. I haven't pulled this image since April, so it's not there. Let's see, any other questions?
Yeah, it looks like we've got a question from Julian Silverstein asking about some advice for using only cloud build for CI/CD. Like, would that be an advisable way to go, and whether or not we could combine security scanning with other tools as well?
So here's what my experience tells you. So cloud build is going to be really useful for both CI and CD. It's fully managed and it scales for you. So you, as a team, don't have to build out CI/CD toolings. You don't have to build out Bamboo or Jenkins or TeamCity and make sure it scales and changes. However, the truth is that most companies adopt one or more of these tools into the development workflow for very specific reasons. So when working with Google Cloud Build is a really, really good fit, especially because it has access to the rest of the parts of your project that you might need to do. So if you want a secure deployment mechanism, it's there. If you want a secure attestation mechanism, it's there. You're not going to leak keys all over the place. You can use Secrets Manager and KMS in with Cloud Build. So it's a really great choice for deploying inside of Google Cloud, or if you're using Kubernetes and Anthos, combining with those two things and ACM, which is Anthos Config Manager, to deploy across your entire multi-hybrid cloud Kubernetes deployment.
Very, very cool. I mean, using Cloud Build for me has personally been really handy, just because, like, before we were doing, everyone was doing Docker builds, and then you'd have to run Docker deploy, and I'd always forget to run Docker deploy. And so then I'm over here looking for my image. I push maybe a Kubernetes deployment, and it's like it fails because of course the image isn't there, and I'm like, what's going on? And so then I started using Cloud Build, and I was like, wait, what about the deploy step? I always forget the deploy step, but like, where is that? And it's rolled right into it. And I was like, oh, this is genius. Why doesn't we should just do this all the time?
It is, and so where the big wins are, and I think we should probably do another cloud talk on this another time, is when you combine Cloud Build with Cloud Code, which is an extension for IntelliJ video code, and Scaffold. So Scaffold is a great way to combine your local development cycle with your enterprise development CI cycle. You combine all of those things and it just works. And I think we just launched a new version of Cloud Code that includes debugging Kubernetes live, which has always been a problem. Once you deploy your container to Kubernetes and something goes wrong, how do you find out without a whole lot of printf? So because printf debugging is only so good.
It's everybody's favorite thing.
Yeah, it's what a lot of people do. But if you actually want to do a live debug session, you can now do that with Cloud Code.
It's amazing. Yeah, I mean, I've heard a lot of good things about Cloud Code. I've seen folks do amazing stuff with it, and so it's really exciting to see more features come to that. And I think you're right that we do need to find somebody to give us a little rundown on what the latest and greatest is with Cloud Code in the future.
Absolutely.
We have a question on the live chat from Julian. Looks like a follow-up question potentially. He says, I love Cloud Build frees you from gatekeeper and to manage something else, but it's not very known. People think CI/CD as something else. Ah, interesting. So associating Cloud Build with kind of the CI/CD workflow isn't something that's present today.
Yeah, I mean, so Cloud Build is a relative newcomer compared to what's used in most places. Like most companies are still using Jenkins or TeamCity from JetBrains or Bamboo, but having managed a lot of these systems, I can say that Cloud Build is easier to manage because you don't have to manage it. And also, one of the things that Cloud Build does that I really appreciate, Jenkins has implemented this some, and some of the other systems have started to do it this way. But for most of my career, as the release engineer, it was my responsibility to configure the build system for developers, to either write the scripts or the pipelines or whatever, we didn't call them pipelines then, or to go in the web tool and click, 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 click. And we did this for them to avoid them getting messed up, and we became a bottleneck. But now the new way of doing this is that engineers themselves, all the developers themselves, are responsible for and capable of affecting how their build works. It's checked in right along with their code. So in a declarative syntax, they keep that up to date with the code that they're building. If there's an error in the build file, they can do a PR and we can all review it and say, yes, that's a good introduction. We can actually also do something where we share duties. We can actually have the YAML that does the security parts of the pipeline, while they do the YAML that does the build and test part of the pipeline. Shared responsibilities, all checked in with the code and all going through code reviews rather than a bunch of clicky boxes in a web tool. Stored in a database somewhere, somebody changed it, it's broken now, who knows why. But yeah, Cloud Build is a relative newcomer.
Yeah, and Julian also says that the session on Scaffold would also be really useful. Is that something that Google made, or is that an open source tool from the community?
No, it's both. Google made it, and it's open source.
Fantastic.
Yeah, talk to me later. I would love to actually put something together for that, to show that world off.
Yeah.
The new Cloud Code, I got introduced to live debugging, and basically you use scaffold, use cloud code, log debugging in a Kubernetes cluster, and I was a little wow. So
the real end-to-end workflow of kind of automating everything. It's really cool to hear about kind of the background of, you basically, Cloud Build, what it does used to be a team of engineers and is now a tool that is used by a team of engineers.
that's right. It reduces the workload on your platform engineering crew, which used to be called your release engineering crew or your DevOps or whatever. But the people who are building the development pipeline, there are a whole list of things they don't have to do anymore. And I'm for it.
Well, amazing. I think that's a perfect way to sum it up, and we can leave it there for
All
folks to mull it over. And yeah, thank you so much for sharing with us your kind of incredible wisdom and depth of knowledge on cloud build, vulnerability scanning, attestations, words that perhaps I wouldn't have necessarily come across in these times, but some new terminology learned today for myself and hopefully for our viewers out there. And I guess, yeah, looking ahead, the next Tuesday, be sure to join us for more Google Cloud Talks by DevRel. We've got 3 speakers kind of talking about practical AI, talking about building conversational AI. They're going to be using Dialogflow and speech APIs. We're going to do machine learning with Google Forms. So that's going to be really exciting, kind of cross-pollinating some ideas from the, not typically ML world, right? Using Google Forms and other productivity software. And finally, applying AI to document understanding. So that's going to be really exciting. That's also kind of a really rapidly growing field of where you can apply AI. So really looking forward to that. Thank you so much, Don and Jaana, for joining us today. And yeah, and thank you everyone out there. Be safe, be well, and we will see you next week.